All right, Algebra 2, welcome back with our next lesson today. So here's kind of like what's going on for this next unit. I know it's kind of like up in the air. So first off, you guys did really well for all the confusion on your quiz history. So I want to say I'm really proud of you guys. I know graphing rational functions and doing all that is not easy. I want to say I'm really proud of you guys. Again, just hope you're being your best and honest selves, because even though I know it's at home and I'm not watching you, and it's not, it's multiple choice, I get all that, but this material you still need to know for next year. So I know I'm assessing you on it. I'm doing as best as I can from far away, but hopefully you guys are really learning this stuff, and you're not just doing the quiz. And like I said, I mean, if you whatever, just make sure you are truly learning this stuff, because you do need to know it for next year. Whoever the right now to Mr. McNulty, whoever the pre-calc teacher is, will expect you to know this material. So again, I really need to emphasize that. I'm trying to do the assessments as meaningful as possible, but you still need to make sure you're learning the material. So I just wanted to say that. But I really am proud of all of you. I'm assuming you guys are your best and honest selves, so I'm really proud of the performance on that quiz yesterday, because I know that's a very hard concept. So what's kind of the plan for the rest of this unit? So that's part of it, the graphing rational functions. That'll be on the next test, along with we're going to learn how to solve rational equations and how to solve rational inequalities. So we have really two more sections to do. So we've learned graphing, all the graphing, that was 2 parts. We're going to have one lesson on rational equations. You'll have an assignment on this on Monday. Then you'll have rational inequalities, an assignment on that on Tuesday. You'll have that video, an assignment on that on Wednesday. Then I'm thinking probably a test Thursday on graphing, the rational, like what we had the quiz on, then the rational equations and the rational inequalities. All right? Again, you guys have any other questions, please feel free to reach out to me. I was very proud of the performance on that quiz. So today we're going to learn how to solve rational equations. This is going to kind of bring in the skill of when we were simplifying the addition, subtraction, rational expressions. We're going to be kind of doing that. We're actually going to be solving for an answer now. We're also going to get to this thing called extraneous solution, which I will explain when we get there. But there's going to be one new term we're going to learn about extraneous solutions. All right. So today we're going to do 7 problems. All right. So we have first 2 up here. I'm going to try and do the next 7. So not too bad, and they don't look as crazy. They're not as bad as they look. All right. So let's start out with this first one, number 1 here. All right. So I have 3 over t minus 1 over 3t equals 2 over 3. Okay, the first thing I want to do is, if I don't see how these 2 fractions are equal to each other, which we'll get to this one in a second. If I don't have 2 fractions exactly equal to each other like this, what I have to do is I have to find first a common denominator. Okay, remember we were finding a common denominator? All right, so let's do that first. So here, all right, well, we see at the bottom, we have a 3 and a t, at least in all of the bottom things, right? My common denominator here is going to be 3t. So when I do that, right, I'm going to get, so once I get my common denominator, I'm basically going to eliminate the bottom here. So the bottom, if the common denominator is 3t, right? So this would become, so here I would have to have a 3 added onto that. So this would be, I would multiply the top, so I multiply the bottom by 3, so it's going to be 9 over 3t. Right, because that's what changed. I multiply the bottom by 3. This is going to stay. And then over here, I multiply the top and bottom by t, right? Okay, so once I do that, so once I make my common denominator, what I'm going to do is, I'm not going to do any division here. I'm just basically going to eliminate my denominator. That's what I'm going to do. I don't even need to worry about it. So what I'm going to do is, now that I have a common denominator, I multiply the tops to everything I multiply the bottom by. This is going to become 9 minus 1 equals 2t. Just deal with the numerators, the numbers at the top. So once you get your common denominator and multiply whatever you added to the denominator to the top, then just take your numerators and solve. So here I'm going to get 8 equals 2t. All right, now we're going to divide by 2. To get t, so t here is going to equal 4. Okay, now with these rational equations, every time I get an answer, I have to check to make sure it works, because there are going to be sometimes answers that don't work, even if I get the answer from solving, and there's going to be extraneous solutions, and we'll get to those in a second. All right? So, t equals 4, right? So let's plug in 4 for t and see if it gets me the right answer, right? So I plug it in. I'm going to get 3 over 4, right? 3 over t, 3 over 4, minus 1 over 12, 3 times 4, equals 2/3. So all I did was plug in 4 for t. Now if I do 3/4 minus 1/12, I will get 2/3. So t equals 4 is my answer. So I do have a solution here. T equals 4. So again, when I do 3/4 minus 1/12, I get 2/3. These should be equal. Like I should be able to plug 4 in and get the same thing on either side. So again, you always have to check. I know it's annoying. You have to check to make sure it's an answer. So t equals 4. That's my answer there. All right? So that's the first problem. All right, so next. Let's say I do see two exact fractions equal to each other, like 1 over x equals 2 over x minus 3. These are actually much easier to do. Can I make a common denominator and do all that and bring it to one side and all this nonsense? Yeah. Easier. If I see two fractions like this equal to each other exactly, all right? All I have to do here is, only happens in this special case, all I have to do here is cross multiply and then solve. So what I'm going to do is I'm going to cross multiply. So I'm going to multiply 1 times x minus 3 and 2 times x. So I'm going to get x minus 3 equals 2x. Alright. Then I'm going to bring all the x's to this side. So I'm going to subtract x on each side. This is x minus 3. I'm going to subtract x on each side to solve. And I'm going to get negative 3 equals 2x minus 1x, which is just x. X equals negative 3. So now again what I have to do is, once I get my answer, or answers, I have to check to make sure one or both of them work. So I'm going to do 1 over negative 3 should equal 2 over negative 3 minus 2, which is negative 9. If you simplify 2 over negative 9, I would get negative 1/3. So when I plug in negative 3, I get the two same things equal to each other. So x equals negative 3 is my solution. I have no extraneous solutions. So again, what an extraneous solution is going to be is, I'm going to get an answer and it's not going to work. And we're going to get there in a second, all right? And I'll explain that a little more. So here I solved both of these rational equations and they both gave me answers, and they both, when I plugged it back in, they both worked. So you got to check them. That's going to be the, I guess, annoying part for you guys, I know. I know some people are like, do we have to check? Yes, you have to check them. All right. So there's the first two. So we got 5 more to do. Now they're going to get more complicated than this. I mean, not much more, but I mean, like, if you were pretty good at the common denominator stuff in the, when we were adding and subtracting, these problems are going to seem not too bad, because they're using that concept in a way. All right? All right, so let's move on to 3 and 4. All right? So number 3, it's going to look like this. 2 over s plus 3 minus 1 over s minus 3 equals 0. Again, these are s's, okay? And then 4, you have 1 over y minus 2 plus 1 over y plus 2 equals 4 over y squared, right? Y squared minus 4. All right. So, number 3. Okay, so this is going to be, so I know I said when you have it equal 0, yes. Can you get a common denominator for number 3 and do all that? Yes. If I see 2 of these equal to 0, here's what I can do to make this problem much easier. This is only when it equals 0. When it equals like another whole number or some other fraction like number 4, I'm going to have to do the common denominator thing and all that. But if it equals 0, okay, I can actually take this fraction, 1 over s minus 3. I'm actually going to add it to either side, right? So I'm going to move it over here. So I'm going to get 2 over s plus 3 equals 1 over s minus 3. So again, this only can happen when I have it equal to 0, okay? Or if they're equal to each other already, but if it's equal to 0, okay? So now this looks like the set problem we just did, number 2. So what I'm going to do here is I'm going to cross multiply. So I can do that because just two fractions equal to each other. So I'm going to cross multiply here. So I'm going to get, if I do this, I'm going to get s plus 3 equals 2 times s is 2s. 2 times negative 3 is negative 6. Alright. So now I'm going to add the 6 over and bring the s over. When I do that, I'm going to get s equals 9. Alright. Because what's going to happen is if I do that, here I'm going to add 6 to 3 and I'm going to get 9. I'm going to subtract s from 2s, I'm going to get 1s. So s is going to equal 9. Once I get that answer, I now have to what? Check. I have to check to make sure that s equals 9 is going to work in my answer. So the rest is going to be solve and check the entire time. So on the top, I'm going to do my check, right? So I'm going to do 2 over, what's that? 9 plus 3 is going to be 12 minus, what's that going to be? 1 over 9 minus 8, minus 1 over 6 should equal 0, right? So if you do that, right, so that's 2 over 12 is 1/6, simplifies. Well, 1/6 minus itself is going to equal 0, so that works. So that means s equals 9 is a solution. That's my solution, s equals 9. Alright, so I can only do this thing when it equals 0. If it equals to like 2 or something like that, then you have to find the common denominator, do all that. Alright? Alright, number 4 here. Alright, number 4 is we're going to ramp it up a little bit. So I have 1 over y minus 2 plus 1 over y plus 2 equals 4 over y squared minus 4. First off, if I factor this bottom out right, I hope we all know this is going to be y plus 2, y minus 2. I don't need to like show it an extra step. So my common denominator, if we look at everything I have in the bottom, is going to be y plus 2, y minus 2. So if I do that right on the top, so this is going to be y plus 2, y minus 2. I added a y plus 2, so it's going to become the top, right? Plus, I have the denominator, same common denominator. This is going to become y minus 2, right? Because from here to here I gained a y minus 2. And then here, the equals is just going to stay 4. Okay, now like I did in the first problem, once I have my common denominator, I multiply to the top, what I add to the bottom, get rid of the denominators and just deal with the top. So I have y plus 2 plus y minus 2 equals 4. Alright? So all I did was, I just did y plus 2 plus y minus 2 equals 4. I just took the tops of all the fractions. Right? After I found my common denominator and multiplied to the top, I can do that, okay? So when I do this, I'm gonna combine my terms, right? 1y plus 1y is 2y. 2 minus 2 is 0, so the 2's cancel. That equals 4. Divide by 2, y equals 2. Alright. So let's try plugging in 2 and see what happens. All right, let me just look at this for a second. So I get 1 over 2 minus 2 plus 1 over 2 plus 2 equals 4 over 4 minus 4. What's going to happen here? So I'm going to get 1 over 0 plus 1 over 4 equals 4 over 0. I hope we know by now that I can't do anything divided by 0. That's undefined. Alright, so what does that mean for us here? So first off, it means that we don't have a solution. So if you try the one solution you get and it doesn't work or neither of them work, then I have no solution to this problem. No actual solution. But of some other thing I mentioned in the beginning of the video, extraneous solutions, I also mentioned in the first couple problems. I do have an extraneous solution. So an extraneous solution is a solution that you get from the problem, but it does not work as a solution to the problem at hand. So y equals 2 is my, so I have an extraneous solution, like an extra solution, I guess you'd say. But it's called, they use the word extraneous solution of y equals 2. So I have no solution to the problem, but I have an extraneous solution of y equals 2. So 2 is an extraneous solution, not an actual solution to the problem. Because when I plug 2 in, it makes it undefined. That's kind of a key to an extraneous solution. If I get a solution and it makes one of the bottoms 0, think about that, like you made this one 0, or any of the bottoms 0, you can't divide by 0, so that basically means an extraneous solution. So if I get a solution and it makes the problem, the rational equation, undefined, it makes any of the fractions you have undefined, it's an extraneous solution. If it doesn't, then it's a solution probably, but you still have to check to make sure. So in this case, we had an extraneous solution of y equals 2 and no solution, actual solution. So we have no actual solution, but we have an extra solution, an extraneous solution of y equals 2. All right? So if you get two solutions and they both make the denominator 0, they're both extraneous and you have no solution. So that can happen. Or you could get one that's extraneous and one that's not. You might get, if I got two solutions here, I might get, -2, or not -2 won't work. Let's say I got like 4. 4 might work, but we still get 2. So I might have 4 is the solution and 2 is extraneous solution. So you could have both of them be extraneous. You could have one extraneous, one not, or you could have both be solutions. Just depends on the problem. All right? All right, so we got a couple more, right? 3 more? Not too bad. Hopefully this is making sense. Again, if you kind of remember the common denominator stuff from when we were simplifying rational expressions, this stuff isn't too bad. It's just solving now. So you're using that to kind of solve. And then for checking, all you're doing is, kind of people will get confused sometimes, you're just plugging in the answer you got back into the original problem and just seeing does it work. That's all you're doing. All right. So let's jump to 5. All right, so number 5 is going to be 3 over x plus 1 minus 2, or 1, sorry, minus 1 over x minus 2 equals 1 over x squared minus x minus 2. All right, so first of all, I would just factor the bottom here. So this actually becomes x plus 1, x minus 2, okay? So this actually becomes x plus 1, x minus 2, all right? So the first thing I want to do is, I want to find my common denominator. We can kind of see what we have here, x plus 1, x minus 2. That's going to be my common denominator. So to the 3 I'm going to multiply, so it's going to be 3 times x minus 2 over x plus 1, x minus 2, minus 1 times x plus 1 over x plus 1, x minus 2. And this one's going to stay the same. It's going to be 1 over x plus 1, x minus 2. All right, so now remember, I'm going to get rid of the bottom and just have the top. So I'm going to distribute the 3, so it's going to be 3x minus 6 minus x, and you distribute the negative 1, it's going to be minus 1 equals 1. All right. So when I do this, I'm going to get 3x minus 1x is going to be 2x. Negative 6 minus 1 is negative 7 equals 1. I'm going to add the 7, so I'm going to get 2x equals 8. So x is going to equal possibly 4. All right, so let's check the 4. All right, so I plug 4 in. We'll really think about it, guys. Let's just plug it in real quick. So that's going to be 3 over 5. All right, so 3 over 4 plus 1 is 5. Minus 1 over 2, right? 4 minus 2 is 2. Equals, if I plug 4 into here, I would get 1 over 10. If in your calculator you do 3 over 5 minus 1 over 2, you you're going to get 0.1, which is 1 over 10. So 4 is going to work. So 4 is a solution. I would still check it, but you could also see that 4 doesn't make any of the denominators undefined, so it's going to work, probably. But I always double check it because you never know. So that is number 5. All right? Here's what I'm going to do. I'm going to have you guys pause it, try 6 and 7 on your own, and come back. Just give it a shot. All right, welcome back. Hopefully you guys at least tried 6 and 7 on your own, okay? So let's jump to those. Let's do those last two, all right? So you're going to get, for number 6, right? Hopefully at least try to see if you're even getting this or if you're getting anything out of this. So you're going to get 5 over u squared plus u minus 6 equals 2. What's the subtraction? Minus u minus 3 over u minus 2. All right, so first off, we're going to factor out the bottom of this one here. It's going to be u plus 3, u minus 2, right? Key here, guys, when I have this whole number 2, that's technically, if I just have a whole number, that means 2 over 1. So the denominator there is 1. All right, well, if I kind of see what I have in the bottom, I have a u plus 3 and a u minus 2 and a 1. So my common denominator is going to be this. Okay, so here I'm going to have 5 over u plus 3, u minus 2, equals 2 times u plus 3, u minus 2, all over u plus 3, u minus 2. And I multiplied the 2 times both of them because there was no denominator there besides a 1. So I had to multiply the whole thing to the top. And over here, I'm going to have minus u plus 3, u minus 3, over u plus 3, u minus 2. So I multiply u plus 3 to the top of this one because from here to here, I got a u plus 3 added. Okay, so now I'm going to get rid of the denominators, okay, and just have what's left at the top. So I'm going to have a 5 right here, equals. Okay, well, u plus 3 times u minus 2, that is this. If I FOIL that out, that is just this. If you notice, that's what I factored out to be. Remember, whatever it's factored out to be, this is going to be the quadratic. So it's going to be 2 times u squared plus u minus 6. All right? And then it's going to be subtracted by u plus 3, u minus 3. You could FOIL that out. Or, reminder, u plus 3, u minus 3, same number, opposite sign. It's going to be difference of squares. So if I FOIL that out, it's just going to become u squared minus 9. Difference of squares. U plus 3 minus 3 becomes u squared minus 9. Alright, so now I got to do some math here. So I got to rewrite this as 5 equals, it's going to be 2u squared plus 2u minus 12. And that's going to be minus u squared, and then negative minus, it's going to become positive 9. Alright, so now we're going to solve here. So this becomes, alright, I'm going to need some more room, guys, so just give me a second to erase this side of the board. Alright, so now I'm going to keep going here. So now I'm going to combine like terms on this side. Looks like factors come into play with this answer. So if I just continue this over here, right? So it's going to be 5 equals, that's going to be 2u squared minus u squared is going to be 1u squared. 2u, there's no other u, so it's going to be plus 2u. And then negative 12 plus 9 is going to be negative 3. Okay, now you're like, what do I do here? What I would do here, since I have a quadratic I'm trying to factor and I want to solve this, I would bring, if I get to this point where I have like a squared term here, I would bring the 5 over and make it equal to 0. So I'm going to subtract 5 here. So I'm going to get technically u squared plus 2u. Negative 3 minus 5 is negative 8 equals 0. Alright, so now I'm going to factor and solve, right? So if I factor this out, I would get u plus 4, u minus 2 equals 0, right? 4 times negative 2 is negative 8. 4 minus 2 is 2. Now to get my answers, I'm going to set each of these equal to 0, just like I would do to solve any of these quadratics. So I would get u equals -4 and u equals 2. We could check this or just see. Okay, so if I plug -4 in, if I look at this denominators, right, this is just a 1. My original problem started with 4 minus 2 is 2, 4 plus 3 is 7, 4 minus 2 is 2. There is no place that makes any of these denominators going to be equal to 0. So u equals -4 is probably going to be a solution. You can check it just in case, but I'm telling you it's going to be a solution. If I plug in positive 2 though, here it's going to make this denominator 0, 2 minus 2 is 0, I can't divide by 0. Same thing here, 2 minus 2 is 0, anything times that would also be 0. So 2 is not going to work. So what I have is, I have a solution of u equals -4, and then an extraneous solution or extra solution that's not actually a solution of u equals, should be 2. Sorry, it should be 2 extras, 2. So u equals 2 doesn't work, u equals -4 is my solution. So I have one solution, one extraneous solution. Like I said, you could have one of each. 2 doesn't work, because 2, when I plug it in, it'll make a denominator 0. I can't divide by 0. -4 will work though. Alright? Alright, so one more, number 7. Okay? So again, this is just applying that skill of making the common denominator and then solving it instead of just like simplifying it. Basically what we're doing. It's like simplifying the rational expressions with addition and subtraction with an equal sign. Alright? And then after this you'll have assignment, then we'll do inequalities. Be all good. Alright, so number 7, last one, you're going to have 1 over t minus 1 equals 1 over t plus 2. And then what else? Plus 3 over t squared plus 2t minus 2. Sorry. All right. So first I'd factor this out. This would actually give me t minus 1, t plus 2. Okay. That's what that would be factored out to be. -1 times 2 is -2. -1 plus 2 is +1. So these are plus signs. These are t's as part of the solution. So my common denominator, it looks like it's going to be t minus 1, t plus 2. So here I would get t plus 2 times 1 over t minus 1, t plus 2. Again, I'm doing what I did is like I'm multiplying to the top what I multiplied to the bottom as well. So here I would get t minus 1. That's what I'm adding to the denominator, so I multiplied it times 1. These aren't going to cancel because that's what I'm multiplying to the top because I'm multiplying it to the bottom. Don't be like, wait, why didn't you cancel that? These I'm multiplying to the top because I'm making a common denominator here. So then the 3 would just stay the way it is. Because the 3 I didn't add anything to it. Alright, so then I just get rid of the bottoms, I just keep the top. So I have t plus 2 equals t minus 1 plus 3. So that's going to be, sorry guys. Oh, my apologies guys. This should be a t up here. I'm sorry. So this should be t times t plus 2. I was wondering why it didn't come out the way I wanted it to. Alright, so then this is going to stay the same. This is going to become t squared plus 2t. Alright. So here what's going to happen is, so -1, combine like terms on that side, so it's going to be t squared plus 2t equals t, -1 plus 3 is going to be 2. So I'm going to bring the t over and bring the 2 over here. So I'm going to get t squared plus 2t, or plus t, sorry. So what I'm doing here is, guys, is I'm subtracting t and subtracting 2 on this side. So I would get, I'm going to carry it over here, I'm going to get t squared minus, or plus t minus 2 equals 0. So just like I did in the last problem, now I'm going to factor this out. Oh wait, this looks similar to the start out problem there. So what would I get? I would get t minus 1 t plus 2 is equal to 0. So my two answers here are going to be t equals 1, or possible answers, or t equals negative 2. Well, let's see, if I plug in 1, right, will make my denominator 0. Of course, you're not here to answer me, but yes, it would, right? 1 minus 1 is 0. 1 minus 1 is 0. Anything I multiply by that would also give me 0. Negative 2 would also give me 0 to the denominator right here and here. So in that case, guys, since that happened, there is, to this problem, after all that work, no solution to this problem, to this rational equation. But I have two extraneous solutions. Okay, you're not always going to have them, but two extraneous solutions of t equals 1 and t equals negative 2. So again, if they're both extraneous, you don't have an answer. You do write no solution. So if I asked you, like, find the solution of this, I might say, like, I might have one of the answers, no solution. Like, you have to pick that. But there's extraneous, yes. So that's it, guys. Those are rational equations. So have a good weekend. Enjoy your Friday, and I'll see you guys back on Monday for more assignments. Have a great day.